If A is equal to a 3 by 3 matrix 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, then verify that we need to show that a power 3 minus 6a square plus 9a minus 4i is equal to 0. So here we can consider an identity matrix. I is equal to, in 3 by 3 matrix we can take 1 0 0 0 1 0 and 0 0 1. So let's find a square, which is a into a is equal to, so we can write 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 multiplied with again 2 minus 1 1 minus 1 2 minus 1 1 minus 1 and 2. Let's multiply using row with column. The first row with first column, 2 into 2 4, 4 minus of minus 1 plus 1 5, 5 plus 1 that is 6. Row with the second column, negative 2 into minus 1 is negative 2, negative 2 again minus 4, minus 4 minus 1 is minus 5. And next the third column, 2 into 1 2, 2 plus 1 3, 3 plus 2 is 5. And second row with first column, minus 2 minus 2 minus 4 minus 4 minus 1 is minus 5. And again second one, 1 plus 4 5, 5 plus 1 it's a 6. And again third, negative 1 negative 2 negative 3 negative 3, again negative 2 that is negative 5. And next 1 2s are 2, 2 plus 1 that is 3, 3 plus 2 it's 5. And again third row is second column, negative 1 negative 2, negative 3 negative 3 negative 2 is negative 5. And again 1 plus 1 2, 2 plus 4 that is 6. So we have 6 minus 5 5, 5 minus 5 6 and minus 5, and 5 negative 5 and 6 is a square. Now a cube is equal to, we can write a square into a, which is equal to, so we can write 6 negative 5 and 5 minus 5 6 and negative 5, 5 minus 5 and 6 is multiplied with the given matrix A, that is 2 negative 1 and 1 minus 1 2 and minus 1 1 minus 1 and 2, which is equal to, again row with column, first row 6 2s are 12, 12 plus 5 17, 17 plus 5 22. And again first row with the second column, negative 6 negative 6 negative 10, that is minus 16 minus 16 minus 5 minus 21. And row with the third column, 6 plus 5 11, 11 plus 10 that is again 21. Next number minus 10, second row with the first column, minus 10 minus 6 minus 16 minus 16 minus 5 is minus 21. And again second row second column, 5 plus 12 17, 17 plus 5 22. And again second row with the third column, negative 5 negative 6 negative 11 negative 11 and again negative 10 minus 21. Next third row with first column, 10, 10 plus 5 15, 15 plus 6 21. And again third row with the second column, negative 5 and negative 10, negative 15 negative 6 is negative 21. Third row with the third column, 5 plus 5 10, 10 plus 12 22. So this is a cube value. And now let's consider a power 3 LHS minus 6a square plus 9 times a minus 4 times I. So we can write here a power 3 is 22 minus 21 plus 21 minus 21 plus 22 minus 21 and 21 minus 21 and 22. So this is a power 3 minus 6 times of a square. Let us multiply 6 to the a square. So here a square, 6 is multiplied, 6 6 are 36, 6 5 are 30, and again 6 5 are 30, 6 into negative 5 is negative 30, 6 into 6 36, 6 into negative 5 is negative 30, and again 30 here, negative 30, and again 6 6 are 36, plus 9 times of a matrix A, that is 9 is multiplied with A matrix, so 9 2s are 18, minus 9 and plus 9 and again negative 9, 9 2s are 18 and 9s are 9 and again 9, here negative 9 and 9 2s are 18. Again minus 4 times of an identity matrix, that is 4 0 0 0 4 0 0 0 4. Now let's simplify here. We will be getting, so 22 minus 36 plus 18 and minus 4. So we have 18 minus 4 is 14. So 14 plus 22 is 36. 36 minus 36 is 0. So I can write here 0 is the first element. And similarly the second element, minus 21 plus 30 is 9. 9 minus 9 it's a 0. And 21 minus 30 is negative 9 plus 9 is 0 again. And similarly we can simplify the remaining, minus 21 plus 30, 9 minus 9 0. And here 22 minus 36 and 18 minus 4 14. 14 plus 22 is 36 minus 36 is 0. And minus 21 plus 30 is 9. 9 minus 9 it's a 0. And 21 minus 30 is negative 9 plus 9 it's a 0. Minus 21 plus 30 is 9. 9 minus 9 it's a 0 again. And 22 minus 36 is minus 14. And again here 18 minus 4 is plus 14, so 0. So we can say that the answer is 0 and hence verified it. So we just verified a power 3 minus 6a square plus 9a minus 4a is equal to 0. Now we shall find the A inverse. So to find A inverse, let's find the determinant of a matrix A. Det A is equal to, let's expand by using the first row. So 2 times of 2 to the 4 minus 1, that's 3. Negative of negative 1, that is plus 1 times. 1 into 2 is negative 1 is 2 is minus 2 plus 1, that's negative 1, plus 1 times of 1 minus 2 is negative 1. So which is equal to 6 minus 1 minus 1, that is 6 minus 1, 5, 5 minus 1 is 4. So delta is not equals to 0. So we can conclude that A inverse exists. So to the equation, let us pre-multiply A inverse on both the sides. A inverse of a power 3 minus 6a square plus 9 times a minus 4 times I is equal to A inverse into 0 matrix. So which can also be written A inverse into A power 3 we can write A square into A. So we can write A inverse into A square minus 6 times of A inverse into A square we can write A into A plus 9 times of A inverse into A minus 4 times of A inverse into I is equal to A inverse into 0 will be 0 matrix. So A inverse into A is, we know that A inverse into A is equal to I, and I into any matrix or A into any matrix we can write A. So A inverse into A is identity matrix. I into A square minus 6 times of A inverse into A is again I into A plus 9 A into A inverse is I minus 4 times of A inverse into I is A inverse, which is equal to 0. Or I into A square is A square minus 6 into A plus 9I minus 4 times A inverse is equal to 0. Or we can also write 4 times A inverse is equal to A square minus 6A plus 9 times of I. Let us simplify this. A square is 6, negative 5 and 5, minus 5, 6 and negative 5, and 5, negative 5 and 6, minus 6 times of matrix A. So let us multiply 6 to the matrix. 6 2s are 12, negative 6 and 6, negative 6, 6 2s are 12 and negative 6, and 6 and negative 6 and 6 2s are 12, plus again 9 times matrix we can write 9 0 0 0 9 0 0 0 9. So which is equal to 6 plus 9 15, 15 minus 12 is 3, and here negative 5 plus 6 1, so we can write here 1, and 5 minus 6 is negative 1, and negative 5 plus 6 6 minus 5 1, and 6 minus 12 is negative 6, 9 minus 6 is 3, and negative 5 plus 6 6 minus 5 is 1, so we can add 1 here, and 5 minus 6 negative 1, and negative 5 plus 6 is 1, so we can write this as 1, and 6 minus 12 is negative 6 plus 9 is 3, So we got 3, 1, minus 1, 1, 3, 1, negative 1, 1 and 3. So we can write here from here. So therefore A inverse is equal to this 4 will come here 1 upon 4 times of 3, 1, minus 1, 1, 3, 1, negative 1, 1 and 3. So this is A inverse for the given question. Okay, thank you.
If A is equal to 1, 2, 1, 1 minus 1 minus 2, 1, 1, 3, find A inverse. Using A inverse, solve the system of linear equations. X plus y plus z is equal to 3, 2x minus y plus z is equal to 2, and x minus 2y plus 3z is equal to 2. So let us find A inverse. Determinant of A is equal to 1, 2, 1, 1 minus 1 minus 2, 1, 1, 3, which is equal to 1 times of minus 1 into 3 minus 3 plus minus 1 into minus 2 is negative 2, so minus of minus plus 2 minus 2 times of 1 into 3 3 minus 1 into minus 2 is negative 2, so negative of negative positive 2 plus 1 times of 1 into 1 is 1 minus of minus plus 1, which is equal to 2 minus 3 is negative 1, 3 plus 2 5, 5 into minus 2 is minus 10, 1 plus 1 2, so we have 2 minus 10 is minus 8, minus 1 minus 9. So here we can say det A is equal to minus 9, which is not equals to 0, and hence we can say A inverse exists. And now A inverse is equal to 1 by det A into adjoint of matrix A. So let us find the adjoint of a matrix. So let us consider from the matrix A, from second row second column elements minus 1, then minus 2, and again come to the first element 1, then again end up with minus 1. This is from second row. Similarly third row, next continue with the third row, second element 1, and then next 3, next come back to 1, and again end up with 1. Now coming to the first row, 2, then next 1, and again with 1, end up with 2, and again now end up with the same second row. We can write minus 1, minus 2, 1 and minus 1, so that we can find the adjoint here. Adjoint is nothing but transpose of cofactors matrix. So 1 upon minus 9 into, so minus 1 into 3 minus 3 and plus 2, minus 3 plus 2 is minus 1, and here since it is a transpose I will take vertical and I will write horizontal. So 1 ones are 1 minus 6 is negative 5, and 2 into minus 2 is minus 4 plus 1 is minus 3, and minus 2 minus 3 is minus 5, and 3 ones are 3 minus 1 is 2, and 1 ones are 1, 1 plus 2 is 3, and again 1 ones are 1 plus 1 is 2, 2 ones are 2, 2 minus 1 is 1, and 1 into minus 1 is minus 1, minus 2 is minus 3. So we got the A inverse 1 upon negative 9 into 1 minus 1 minus 5 minus 3 minus 5 2 3 2 1 negative 3. Now the given system of equations, x plus y plus z is equal to 3, and 2x minus y plus z is equal to 2, and x minus 2y plus 3z is equal to 2. The given equations we can write in matrix form as 1 1 1 from the first equation, second equation 2 minus 1 1 coefficients, and third equation 1 minus 2 and 3. into x is equal to the variables here x, y, z is equal to the constants are given here 3, 2 and 2. And here we can see that let us consider it is in the form of bx is equal to some matrix P. It is in the form of like ax is equal to b or bx is equal to p, where we can see that b is equal to, so 1 1 1, it's nothing but transpose of a. So b inverse is also a transpose whole inverse. So we can write a transpose whole inverse is equal to a inverse whole transpose. So already we got a inverse is equal to 1 upon minus 10. Let us do transpose for this so that we will be getting the b inverse. And hence we can use by solving x is equal to b inverse into p. So x is equal to b inverse into p. So we can write minus 1 by 9 times minus 1 minus 5 2 minus 5 2 and 1 minus 3 3 and minus 3 multiplied with the matrix P, constant matrix, that is 2 3 2 2, which is equal to minus 1 by 9 times matrix multiplication row with column. So minus 1 into 3 is negative 3, minus 5 into 2 is negative 10, and 2 into 2 is plus 4, and the second row minus 5 into 3 minus 15, and plus 2 into 2 4, plus 1 into 2 is 2, and third row minus 3 into 3 negative 9, and 3 into 2 plus 6, and again minus 6. So we can write minus 1 by 9 times of minus 13 plus 4 is minus 9, and here it is minus 15 plus 6 is minus 9, and again minus 9. On simplification we'll be getting minus 9 is taken common, so 9 out of 9, 1 1 1. So we can consider xyz is equal to the matrix x is equal to xyz. So the matrix xyz is equal to 1 1 1, which implies x is equal to 1, y is equal to 1, z is equal to 1. So let us verify with by substituting anywhere in any one of the equations. So let us substitute in the third equation 1 minus 2 plus 3. So 1 minus 2 minus 1 plus 3 is 2. So which is correct. So we can say that x is equal to 1, y is equal to 1, z is equal to 1 is the solution. So by A inverse we solved the equations. Let A, B and C be three vectors such that mod A is equal to 1 and mod B is equal to 2 and mod C is equal to 3. If the projection of B along A is equal to projection of C along A and B and C are perpendicular, then find the value of mod of 3A minus 2B plus 2C. And it's given mod A is equal to 1, mod B is equal to 2 and mod C is equal to 3, and also projection of vector B along vector A is equal to projection of vector C along vector A, that is B dot A upon mod A is equal to C dot A upon mod A, which implies B dot A is equal to C dot A. And it is also given vector B and C are perpendicular. Vectors B and C are perpendicular, so which implies that B dot C is equal to 0. So to find mod of 3A minus 2B plus 2C, let us consider mod of 3A minus 2B plus 2C whole square, which is equal to, since mod A square is equal to a dot a. So we can write 3a minus 2b plus 2c dot product with 3a minus 2b plus 2c, or the simplification we can write directly here, mod of 3a whole square plus mod of minus 2b whole square plus mod of 2c whole square plus 2 times of 3a dot minus 2b, and again plus 2 times of minus 2b dot 2c plus 2 times of 2c dot 3a, which is equal to mod 3a square is 9 times mod a square, and minus 2b mod whole square is equal to, since it is a square, so you can take 4 times of mod b whole square, and here it is 4 times of mod c square, and here it is minus 12 times of a dot b, and here it is minus 8 times of b dot c, and again here plus 12 times of c dot a. And we know that a dot b is equal to c dot a, or b dot a is equal to c dot a. So we can write here 9 times mod a value is 1, 4 times mod b is 2 square, plus 4 times mod c value is 3 square, minus 12 times of a dot b, and since b dot c is equal to 0, and here 12 times of c dot is nothing but b dot a, and we know b dot a and same as a dot b, so we can write a dot b, so that we can cancel these both, and this is 0. So finally we have 9 times of 1 square is 9, 4 times of 2 square is 16, and 4 times of 3 square is 9 4s are 36. So we have 25 plus 36, that is 61. So therefore mod of 3a minus 2b plus 2c is equal to under root of 61. So root 61 is the answer. Sketch the graph y is equal to mod of x plus 1 and evaluate integral minus 3 to 1 mod of x plus 1 dx. What does this value represent of the graph? And mod of x plus 1 we can write it as x plus 1 when x plus 1 is greater than or equals to 0, that is x is greater than or equals to minus 1, and negative of x plus 1 when x plus 1 is less than 0, that is x is less than minus 1. So we can consider now y is equal to x plus 1 whenever x is greater than or equals to minus 1, and minus x minus 1 whenever x is less than minus 1. Let's see the graph. For x is greater than minus 1, the graph is x plus 1. So we can draw the graph. When x is equal to 0, it is 1. So, and when x is equal to minus 1, it is 0. So we'll get the line. So this is y is equal to x plus 1. And for x is less than minus 1, the graph will be negative x negative 1. So we can say for x is equal to minus 2, so it is 1. For x is equal to minus 3, it is 2. So we can say the graph can be taken. So this is y is equal to negative x negative 1. And now our question is integral minus 3 to 1 mod of x plus 1 dx. So we can see that from minus 3 to plus 1, it is negative x negative 1. We can draw x is equal to minus 3 line, and at x is equal to minus 1, and here at x is equal to plus 1. So the shaded region can be, or the required area is, so we can write integral minus 3 to minus 1 mod of x plus 1 can be taken as minus x minus 1 dx, and again from minus 1 to plus 1 mod of x plus 1 we can take it as x plus 1. So below minus 1 minus x minus 1 function, and above 1 is x plus 1 function. So upon simplifying, we can write negative x square by 2 minus x over the limits minus 3 to minus 1, and here x square by 2 plus x over the limits minus 1 to plus 1. So which is equal to, we can write negative of 1 by 2 minus of minus plus 1, upper limit minus lower limit is minus of minus 3 whole square, that is minus 9 divided by 2 minus of minus plus 3 minus the lower limit can be taken as, the lower limit is, so upper limit for the next function 1 square upon 2 plus 1 upper limit minus lower limit can be taken as minus 1 whole square is 1 by 2 minus 1. So we can add 1 minus half is half, and this is 3 minus 9 by 2 is minus 3 by 2, that is plus 3 by 2, and again here plus 1 by 2, 1 square by 2, that is 1 by 2 plus 1 is 3 by 2 minus 1 by 2 minus half is minus half, that is minus of minus plus half. So 3 plus 1 4 by 2, that is 2, and again here 2, so 2 plus 2 is 4 units. So 4 square units is the area covered under this graph with respect to x-axis. Using integration, find the area of the region bounded by the line x is equal to 2y plus 3 and the lines y is equal to 1 and y is equal to negative 1. Let us sketch the graph. The x is equal to 2y plus 3. So by taking y is equal to 0, you get x is equal to 3. So 3 comma 0 is 1 point. Or by x is equal to 0, you will be getting y is equal to minus 3 by 2, that is minus 1.5, 0, 0 comma minus 3 by 2. So the graph can be taken, and now the lines y is equal to plus 1 and y is equal to negative 1. So y is equal to plus 1, we can write the horizontal line which is parallel to x-axis. So this is y is equal to plus 1, and y is equal to negative 1 is also a line which is parallel to x-axis passing through the point 0 comma minus 1. So y is equal to negative 1, and clearly we can see that the area of the region bounded by this line and the lines y is equal to 1 and y is equal to minus 1. So by using integrations we can find the required area is equal to integral. So let us consider from minus 1 to plus 1. Minus 1 to plus 1, the curve is, or we can write x dy. So where the curve is taken 2y plus 3. So integral minus 1 to plus 1 2y plus 3 of dy, which is equal to
Integration of 2y is 2y square upon 2 plus integration of 3 is 3y over the limits from -1 to +1. So which is equal to y square, that is upper limit is 1 square minus the lower limit is -1 whole square plus again here 3 times of upper limit is 1 minus the lower limit is -1, which is equal to 1 minus 1, that is 0, and again here 3 plus minus of minus plus 3, so which is equal to 6. So the area of the region is 6 square units. Let f from r minus -4 by 3 to r be a function defined as f of x is equal to 4x upon 3x plus 4. Show that the function f from r minus of -4 by 3 to the range of function f is 1 to 1 and on to, and hence find the range of f. So for 1 function, to show that the one function is 1, consider f of x1 is equal to f of x2 implies x1 is equal to x2 for x1 comma x2 belongs to the domain of the function, that is r minus of -4 by 3. So let us consider f of x1 is equal to 4x1 upon 3x1 plus 4 is equal to 4x2 upon 3x2 plus 4, which implies 4x1 times of 3x2 plus 4 is equal to 4x2 times of 3x1 plus 4, which implies 4 3s are 12 times of x1 x2 plus 4 4s are 16 times of x1 is equal to 12 times of x1 x2 plus 16 times of x2. So we can cancel here 12 times x1 x2, and here we can write 16 times of x1 is equal to 16 times x2, that implies x1 is equal to x2. So we got f of x1 is equal to f of x2 implies x1 is equal to x2, and hence we can say that f is 1 to 1 function. And now let us consider onto function for every y belongs to the range of the function, or y belongs to R, we can say real numbers. Here codomain is R. For every y belongs to R, there exists at least one x belongs to R minus of -4 by 3, such that f of x is equal to y. So let us consider f of x is equal to y, 4x upon 3x plus 4 for x not equals to -4 by 3. Let us consider to be y, so that y is equal to 4x upon 3x plus 4, which implies 3xy plus 4y is equal to 4x, or we can also write 3xy minus 4x is equal to -4y, or we can write 4x minus 3xy is equal to 4y, or taking x common, 4 minus 3y is equal to 4y, or x is equal to 4y upon 4 minus 3y. And here we can say that 4 minus 3y cannot be equal to 0, that is y should not be equal to 4 by 3. So we can say that the range must be all the real numbers except 4 by 3. So the range of the function can be taken as r minus of 4 by 3 for the function to be f is 1 to 1 and on to. So here we can consider for x is not equal to minus 4 by 3, for y is also not equals to 4 by 3. So the range is r minus of 4 by 3. Function is 1 to 1 and on to.